All right, Saxon 6, let's begin lesson 32. You can tell from your book the title of the lesson is both expanded notation and elapsed time. Saxon 6 loves to combine several things into one lesson, especially if they think it is primarily review. Let's go ahead and start in on the lesson. I'm going to try to do this all in one film clip today. That means you will see me shuffling some papers. Let's begin by reading our new lesson, Expanded Notation. Recall that in our number system, the location of a digit of a number in a number has a value called its place value. Consider the value of the 5 in these two numbers. In 250, the 5 really doesn't mean just 5. It is in the tens spot. Therefore, it has a value of 5 groups of 10, and it really has a value of 50. In the number 520, the value of the 5 is not just 5, but 5 groups of 100, and really its value is 500. The value of a digit in a number is the value of the digit times the value of the place the digit occupies. In other words, in Saxon 4 and in Saxon 5 and in some of our younger years, we would have said that the 2 in 250 really represents 200. And we would have said that the 5 really represents 50, and the 0 is simply represents 0 ones. In Saxon 5, I believe you learned to write expanded notation in a different way, and we will continue on in Saxon 6 to learn even more ways to write out what a number actually means. Now I'm going to flip pages, and hopefully I can do this without making anyone seasick. I'm going to double check and make sure you can see what I need you to see. I think you can. We write expanded notation when we write each number times its place value. Therefore, now, instead of writing 250 in expanded notation as 200 plus 50, we will write that number in terms of times the value of where the digit sits. So we will write 200 not as 200, but as 2 groups of 100 using parentheses plus 5 groups of 10. All we're doing is getting a little bit more mathematical in the way that we write out and explain what each digit in a number actually means. You'll notice I've ignored the ones place. That's because in this case, the number in the ones place is a 0, so we can just ignore it. It is not necessary to write plus 0 times 1. We get to just omit it. That's the mathematician's way of doing things a little bit cleaner and simpler. Our book lets us know that, however, since 0 times any number equals 0, it is not necessary to include zeros when writing numbers in expanded notation. I'm going to underline that. Let's go on and look at example 2 now. In this case, we've been given a number in expanded notation and we're asked to write it in standard notation. Remember that standard notation is just our usual shorter, faster, easier way of writing numbers. So we're going to look at each parentheses first and solve it. If for any reason you want to make notes above the number, go right ahead. 5 times 1,000 is 5,000. 2 times 100 is 200. 8 times 10 is 80. And now add it all together. 5,200 is 5,200, and 80 more is 5,280. Notice that even though there are 0 ones, it's still important to write the 0 in standard notation in order to make sure the 5 is in the thousands place, the 2 is in the hundreds, the 8 is in the tens, and then the 0 is in the ones. I believe this is all review for you. I think you'll pick it up very quickly and easily. Let's go on and look at the concept of elapsed time. You have been doing problems like this for many years. Today we're just going to look at how we might solve them out, writing out number sentences, and solve it a little bit more mathematically. Let's do a quick review. You know that there are 24 hours in a day and that it's divided into 2 parts. The hours from midnight to noon are the AM hours. The hours from noon to midnight are PM hours. As a quick quiz, ask yourself, do you remember what AM stands for? Do you remember what PM stands for? Come and tell me later if you remember the answers. When we calculate the amount of time between 2 events, we calculate the elapsed time. In other words, the amount of time that has passed. We sometimes think of elapsed time problems as later, earlier, difference problems. We've practiced these before. Let's look at example 3. It says the marathon started at 7:15 a.m. Jackson finished the race at 10:10. How long did it take Jackson to run the marathon? Now in the past, we might have taken a little clock, set it for 7:15, moved it ahead to 10:10, and figured out our hours and minutes. Or we might have gotten to the point where we kind of counted and figured in our head how long Jason took to run the marathon. But today we'll look at another way of perhaps writing out the problem to solve. I better turn the paper around. Here we go. This is really a later, earlier difference problem. I'm going to stack up my papers here. Hang on. Here we go. We know we are trying to find out what Jason's race time was. In other words, the elapsed time. We will do that by subtracting the earlier time from the later time. The difference will be how long Jason spent running the race. So in this case, our later time is 10:10, and we'll subtract the earlier time, the time that he started, as 7:15. While this may look like a typical subtraction problem, you need to notice one important difference. When we go to subtract 10 minutes from 15 minutes, we have to say, bigger bottom, better borrow. So I will come over and borrow an hour from the hour column. Now instead of the hour being 10, it will be 9. And I need to throw my minutes over to the minute column. This is the tricky part. You need to remember that there are 60 minutes in 1 hour. Therefore, I'm going to throw 60 minutes over to my minute column. Now, instead of 10 minutes, I have 70 minutes. And I can subtract. 70 minutes minus 15 minutes is 55 minutes. 9 hours minus 7 hours is 2 hours. And the amount of time Jason spent running that race was 2 hours and 55 minutes. I'm not a marathon runner, but that sounds pretty good to me. Let's look at another problem. In this case, in example 4, we are told or asked, what time is 2.5 hours after 4:30 a.m. This again is a earlier difference problem. Only this time we're told what the difference is. It's 2.5. And we're told what the earlier difference time is. It's 10:43. And we need to know what the later time is. Again, many years ago, you would have taken a little plastic clock, set it to 10:43, and gone ahead 2.5 hours. Or you would have simply counted with your head and your fingers and counted ahead from 10:43, 2.5 hours. But let's see how we might do it mathematically, writing it out as a problem. We know when we have a problem like this set up, if it were a really simple problem like some number minus 3 equals 2, we know to solve for n, we would simply add 2 and 3. The same is true in this problem. We are going to take 10:43 and add 2 hours and 30 minutes. I'm going to turn my page, see if we can find a solution. Here we go. So if I'm writing it out and using a paper and pencil calculation, I'll write out 10:43 plus 2:30. I'll add my minutes. 43 and 30 is 73. 10 and 2 is 12. Now, this is where you need to check yourself. Leaving an answer as 12:73 p.m. is not very mannerly, is it? You need to notice that the 73 is really the same as 1 hour and how many minutes? If you said 13, you were right. And let's rewrite our answer to be completely polite. Let's add another hour onto 12. It's now 1 o'clock something. And 13 minutes. This is where another red flag needs to go off. You have crossed over the magic 12 o'clock hour. That means you've now gone from AM hours to PM hours. So in other words, while our beginning time was 10:43 a.m., 2 hours and 30 minutes later sends us into the afternoon, and we end up at 1:13 p.m. It's important to remember our manners. Would you now please do the following problems in your lesson practice? A, C, D, F, and G. Blessings. Be sure you come and ask if you have a question.